Hello everyone. In this session, we are going to discuss about the different stages of MapReduce. So we will be doing a whiteboarding over there. So let's start. What are the different stages of MapReduce? So there are different stages in the MapReduce. We're going to understand with the help of diagrams. So let me draw the diagram for the different stages of MapReduce. First, we have the HDFS, which is a Hadoop distributed file system. In this, we use a input-output data. And after that, we have mapper, a different mapper phase, we can also call as a mapper phase. Then we have another phase is called LFS, which stands for local file system. After that, we have shuffle and sort. The next stage is local file system again, and we are going to understand each and every phase of this in detail. The next stage is your reducers or reducer. And in the end, we have again HDFS, where we have our output data. So as you know that in a MapReduce, we basically have the data in key and value pairs. This is very important concept to understand or to remember in the MapReduce. Now, so once the data is in your HDFS system, and just to bring back the few important aspects of the HDFS, now we have Hadoop, or we can say Hadoop core components are basically two things. One is Hadoop distributed file system and other one is a MapReduce. This is for a distributed storage. So HDFS is used as a distributed storage and MapReduce is used as a distributed processing. Okay, this thing we have already done in the last session and the last semester also. So now just to understand, the data is loaded into the HDFS, or we can say data is ingested from the different sources to the HDFS, and different sources can be your relational databases, or it can be CSV file, it can be live data. So that means now we have the data in as an input into the HDFS. Now once the data is in the HDFS, now first thing we should understand or we should know about this is what is an input split. So first we should know what is an input split. From the very high level perspective, we can say that your input split is actually a input to a MapReduce. This is an input to a MapReduce job and is divided into your fixed size of pieces, okay, which normally called as an input split. Or you can say that it is a chunk of your input and which is consumed or by a single map. So when I say map, in some context, we also say as a map as a mapper, or sometimes we also say that map task. So all these different words are actually are the same thing. This is very important to remember. Either we can say map task or a mapper or simple map, or sometimes we also call it a map function. Right? So this is about the input split. That means the data which is stored in your HDFS input is actually considered or will be taken in the form of input split. And we are going to discuss this input split in much greater detail in the coming session. So now let's come to the first, or you can say, stage of the different stages of the MapReduce. So now first is your mapper phase. So now we have a mapper. This another is a mapper phase. So now just understand what this mapper phase do or what are the things happens in this mapper. So now you can say that this mapper is actually your first phase or stage of execution. of your map reduce program. So now I will be using throughout this course map reduce as a MR. So whenever you will see MR, just try to understand this is your map reduce. So now this is your first phase or first step or first phase of the execution for the map reduce program. So now you can say that the data in the each of your split is passed to the mapping function. So now what we are saying that the data is passed as an input split to the mapping function just to produce the your output values. Okay. So now in the mapper or in the map task, what happened? We can say that it follows the principle of data locality. The data locality principle says that the computations we are implemented in the map reduce program is actually moved towards the data where the data lies. So instead of moving the data, which is a very large amount of data or big in size, so instead of moving the data, we are bringing the computations to the data. Next, we can say that so in MapReduce we have n number of mapper, right? So we are going to discuss how many mappers should be there in the a MapReduce job. That means each of your map task. So I am actually interchanging the word called sometime mapper or a map task or map. So all the words are same, having same meaning. So each map task operates on single input split, right? So that means what will happen going to happen is there will be one input split in as a data, and that input split is passed to the mapper and the mapper will actually execute. So mapper here it is a computation or is a processing, so which is going to happen on the particular one input split. So there will be one mapper and one mapper will execute the task or processing on the data contained in a one input split. So now what happens, like map output, the map output will be returned to the local file system. So we are going to discuss why local file system sometime in between or HDFS once we are able to understand each and every phase of the map, right? So now after that we have another phase called reducer. So I'm using this space for the reducer. So what is a reducer? So now you can say that the reducer is actually the later phase, but I am trying to use this reducer phase before the shorten shuffle, because shuffle and short is very important phase of the map reducer. We are going to discuss in detail. So now what happens? The in the reducer phase, the output, you can say output values from your shuffling and sorting phase, or you can say from shuffling phase here are aggregated. That means all the output from the shuffle and sort phase are aggregated just to compute the actual results. So in this what will happen, this phase or this reducer combines values from the shuffling phase and returns a single value, returns a single value as an output, right? Now in this reducer, as just compare with the mapper task or mapper phase, there is no data locality principle. The reason is that what happens in reducer phase, what will happen, the data from the different nodes will come to the reducer node, and then where the actual aggregation or any kind of a statistical function will be applied. So in that scenario there will be no data locality principles, and this will be more clearer when we'll do the word count problem, and where we are going to see that how the data from different nodes from the shuffle and sort phase are reaching to the reducer node, and where we are actually applying the aggregation or any kind of statistical function. So that means you can say that The reducer phase will produce your final output, and the reducer output is actually is written to the HDFS, and this is for reliability, because as you know that HDFS is more reliable and it is a fault tolerant, and then replication factor is default by 3, and you can increase or decrease the replication factor, and just because of that HDFS is a more reliable system. Now let's understand in more detail about the shuffle and short phase. So next is your shuffle and short phase. So this is also very important phase in the MapReduce stages. So now what happens in shuffle and short phase, like it actually happens, or this phase happens after all the map tasks, but and before the reducer task starts, right? So this is the phase which is going to happen at the intermediate stage between the mapper and reducer phase. Now you can see that it consolidate and sort all the data from all the mapper tasks. So that means this shuffle and sort phase first try to consolidate and sort all the data from the mapper phase. Now in this you can see that like there is a movement of your intermediate results which is not final. So that means movement of your intermediate records or results from mapper to reducer, that which is actually called as a shuffling. So this is important. So this is called as a shuffling. Now in this phase there is a very important steps called partitioning. So partitioning happens, or you can say partitioning of the data will be there. So partitioning is actually what we are doing in the partitioning is we are dividing we divide based on key value. We are going to see this partitioning in greater detail in the coming sessions. So just partitioning here, what it is doing, it is just dividing your data because the data is in the key value pair, and then this phase will partitioning your data based on the key. So that means key value means I am talking about the value of the key, okay, based on the key. Now we can also say that all the value here, what happens, all the value of same key should land on same reducer. This is very important steps to understand in the shuffle and sort phase, that while doing the computation or while doing the mapping function, after the mapping happens, the results are there into the different nodes, and when the data are in spread into the different nodes, what will happen, the shuffle phase will actually consolidate and then move the data intermediate records from mapper to reducer. In between, what happens, it will sort the data, and now the data is in different nodes of the cluster, Hadoop cluster I mean to say. And when what happens, the data in different nodes are actually travel to the particular reducer. So now here what happens, we have key and value pair in the data, and what will happen, the data of the same key should go to the same reducer. This thing we can understand, or I'll give an example just to make it more clearer, the word example. Let's say you are counting the number of words, right? How many words are there in this book chapter or in this paragraph or in this page, and how many words encounter in number of times. So now let's say while processing these examples, all the mapper do, what the mapper do is like it will add a mapping to one to this each and every word, and that now the word is actually the key, and then value 1 is actually the value of that particular. So now let's take an example that the word called is encounters in this paragraph 10 times. So now there is will be there in different nodes. Somewhere it is one time, somewhere it is two times, or somewhere this data is not available. So now what will happen? Now is this data should move to the or should land to the particular reducer. That means all the is from different node should land to single reducer. In that scenario, what will happen when all the is will land to the same reducer? So what will happen that the reducer will do some aggregation and it will consolidate all the is, and it will check, it will identify, it will calculate that is are 10 times in this data. So in this scenario, if all the is will go to the same reducer, then the result will be true, or it will be the right result. Otherwise, if the same key is moving the data to different reducer, then they will consume the data and they will aggregate the data into different numbers. So that means all the value of is will not be the appropriate. So this is the example to understand, and it will be more clearer when we are going to see the word count problem. Don't worry for that. Now just to briefly distinguish between what is a mapper and what is your reducer, this is the very important. So just on a very high level, what we have done in mapper, the first, in the mapper we extract. In mapper what we do, we extract the data. That means in the mapper, if we take an example of word count, what we are doing, we are taking one word from the whole line. That means we are extracting the data. Then we transform the data. Transform, we can do any kind of transformation. Transformation can be like, let's say an example, your transformation can be, it can be a filter, it can be pre-process, it can be like changing the word from capital to lowercase, or vice versa. Okay, so these kind of different kind of transformation, or we can do some kind of mapping. So if we take an example of word count, what we are doing, from the word we will fetch one word and we will do this is your mapping. Similarly, if I encounter another word, I will put one. That means I am just adding the one word, one as a is as a key and one as a value. So now second step is a transformation. Third is your a little bit of programming we need to do in mappers. So basically we are going to see in throughout the course Java we are going to use in that. And then mapper actually deals with a small amount of data, because the data is chunked into the input split, and because of that. And let's say if we have n number of mappers working, so that means all works in parallel, so that they can execute the task a little fast. So now on the reducer side, what reducer do, it actually do the some kind of aggregation, or it can do some kind of statistical function. Statistical functions can be like count, average, okay, and many more. So now when the map reduce jobs is going to submit, so what will happen? Number of mappers will be there, number of reducer we are going to define, and we are going to see this in detail from the coding perspective also. So now if your map fails, so let's see the another scenario of failure. If your map fails, what happen? Your tasks are going to retry 4 times, and your job are going to retry 2 times. So this is important, you need to remember that. What does it actually means is, what it actually means that whenever a map fails, what happens, a job is submitted, and in job we have a number of tasks, number of maps. So now the task will retry with 4 number of times, and the whole job will retry for 2 numbers time maximum. So now this is all about the different stages of pipelines. So now before ending this, I want to introduce two more important concepts in this MapReduce program. The first one is, what is a driver? So now you can say that the driver is actually your application shell, which you normally invoke, and you invoke it from the client. So that means you can say that when you execute your the program from the command line or command line shell from your laptop, that means this is actually a driver. And you can configure job, submit to resource manager, or you can say or job track. Now these two are very very important daemons. So these are the daemons. We are going to understand these daemons when we do the architecture of the MapReduce. On a very high level note, we can say this MapReduce are of two different version. Different version of MapReduce we're going to understand. One is MRV1 and second one is MRV2. Now resource manager is actually a part of MRV2, or which we normally call as a yarn, another resource manager, or in this is the old version of MRV1. So we are going to see the architecture of both the MRV1 and MRV2 yarn, right, in the coming sessions. So now the driver actually configure the job and submit this job to actually a job tracker, because we are going to study job tracker first. So I'm just using the word job tracker, which is a master daemon over here. Another topic I want to just highlight over in this process or different stages of MapReduce is a combiner. This is another very very important. So combiner, or you can say, can often be defined as reducers, right? But in some cases what happened, but I'm just putting in but, in some cases it needs to be different. We are going to see this combiner again in greater detail once we do the partitioners and combiner in detail. Now you can say this combiner is actually an optional phase. You can skip that phase also, because this is basically used to optimize the performance of your map reduce jobs. In the coming session, you are going to see that combiner code is something similar to the reducer also. So that means your combiner and reducer are sometimes use the same piece of code, or we can use that, because on the top of the hierarchy of the super class, you can say interface, super interface, combiner also uses the same reducer interface. This is a different components of the MapReduce framework. We have different MapReduce framework stages. So we have discussed. So now let's go back to the diagram again so that we can understand in more detail. So now understand again and just try to summarize what we have done so far. The data is stored in the HDFS and the data is brought from different sources to the HDFS. Now this data is your input data, and what happens in input data is actually stored in terms of input split, which is your logical abstraction, and the data is fed to the mappers. Or you can say that the map function takes the data from the input split and it do the processing, and we have n number of mappers based on the configuration what we have done. So we have n number of mappers, and number of mappers are fed to the input splits, and when they process the data is stored in the local file system. So just to understand the meaning of local file system and HDFS, I'm just moving back to the slide. So now you can see that this is your local file system. The local file system is like where your system operating system is stored. So if this is a local file system, now this layer again, the top layer is actually another layer. So this is your Hadoop. So when I say Hadoop, I mean to say that it is using HDFS for storage and MapReduce for processing. The data is actually stored in the local file system itself, but the Hadoop will, or HDFS will be an abstraction layer. So while we install the Hadoop on our machine, or you can say install Hadoop on our local file system, right? So what happens, we usually keep the 75-25% space for the local and Hadoop, and this thing can vary also, but this is my understanding, and this is for local file system. And then local file system is needed for just for a swapping. This is for a temporary space, right? So if I write this local file system is uh, needed for temporary space, temp space, sometime for buffering, sometime for intermediate storage also. Okay, this case in the case what we have what we are discussing in the this module. So just I'm moving back. So now if you see that the output of the mapper phase is going to stored in your local file system. And once the data is stored in the local file system, shuffling and sorting phase happens. Shuffling is what is doing. Shuffling is like moving your data from local file systems or from the mapper output as a reducer input, right? So now shuffling, and there will be sorting also. So what happens? The shuffling and sorted output will also be stored in the LFS. Now, usually what happens? We have a number of mappers and the reducer a little less. So let's say we have n number of mappers and we have only five reducers. So data from the local file system will move to the reducer because LFS in the data of intermediate output of the shuffle and sort are in different nodes, and the reducer might run on different or same node. So this is also possible that reducer runs on different node, and in that case the data from the local file system or output of this shuffle and sort will move to the reducer. And once the reducer process aggregates to the statistical function, the output is now stored into the HDFS. Now the very important question arises, why there is a two different LFS, local file system, not HDFS. And just to understand that HDFS is having their own constraints, like it can store the data but it takes a lot of time, even in retrieving also, and we cannot append the data, we cannot update the data, right? And this again, when we store the data in HDFS, what will happen? It will create a copy, three copies. All the process, it is little costly in terms of storing in that intermediate. And the intermediate results are not that much important because we can generate those data again in case the node where the local file system data is down, right? So now that data, output data from the mapper as well as from the shuffle and sort will stored in the local file system, and reducer output is the actual output we are looking for, and that output data is very important. That is why we are storing this data into the HDFS, and we need a reliability for that. In case the data node is lost, the data is used, HDFS is using, or HDFS is storing the data in three different systems. So that means three redundancy or replication factor. So in that scenario, the data will be safe, even the node is down. But the local file system, if the node is down, we can generate the data again because we have input split, we have the mapper function running in one node, running in a number of nodes, and the daemon process like a job tracker can initiate another map task if the system is down and the map task is running is down because of the node is down. Okay, so this is all about the different stages of the map. Thank you.